Okay, so hi everyone. So today we are going to focus on creating a table to hold the weather data. And one of the reasons we're going to do this is actually for several reasons. But the big one is, even though we obviously are creating kind of the main product is kind of a time series forecasting data set for rivers and streams, we also want to be able to have a table that holds just the weather data, so that then it's multiple, multiple streams often use the same weather station, multiple gauges. We don't have to scrape it multiple times then. That's one of the reasons. And number two is that there might be actually then other analysts and other types of people who want to use kind of the weather data, but they don't necessarily want to they might want to just use the weather data without using the river flow data, number one. And two, some people might have domain knowledge of like, oh, this river, it actually makes more sense to use this weather station even though it's a bit further away. So we want to enable people to be able to then join to that kind of weather data table and query it easily. So we are going to create like just a big table of all the weather data, and then people can hopefully run, ad hoc queries on that. So we want to support that functionality. So those are the major reasons we really want to do that. So yeah, we'll get started with that and then see how far we get. We might only do this a little shorter tonight. But basically, so we start by going into kind of this infra FlowDB again. So we had, we can use our existing things to figure out how to create the tables. So we were going to do one for the scan data now, but actually we'll probably do that in a little bit because I think it's more important to get the weather data table first. And the scan is more just a bonus product. So I'm probably actually not going to add that right now. But we'll actually leave this branch intact probably. Oh wait, that's in the other thing anyways. So what I'll do, well, first actually we'll look at the CSV. So open in Visual Studio Code. So most of what we're scraping right now from the weather station is in this form. Like we have kind of a date time, we have a dew point, we have I don't know what val it is actually, a rain amount, wind direction, and then this weather station we have basically the ID. It doesn't appear is actually saved there, so we actually might edit some of that query too, because I think there are more parameters we can get from ASOS, because really we want to. The idea here is to kind of store everything so that then analysis becomes easier later. Because the idea is basically it's better to pull data we don't need than to repull with data that we kind of do need. So so yeah, we'll just look and see if there's anything else to add to that from the Mesonet API. So again, for this we're kind of using this Mesonet API. So we're using this kind of Mesonet API. from ASOS, and oh yeah, there's actually an all available parameter. So that might be useful to pull. So I'm gonna see how we would update that URL first. Oh, when requesting all stations, that must be. Oh wait, we don't want to do. Yeah, we could do. Format. So I think this is kind of what we'd find in format. Would be all these different values, and we can figure out kind of, I guess, which of these are worth keeping, but we might as well create kind of the schema in a way that will have all these values. And then number 2, I think we're going to actually then put it in like for that station. So yeah, it's actually good here because they're including the station. So we'll just get started on kind of the schema. And oh, this actually does have snow depth, so that's useful because yeah, in some places we might actually, well, we'll still, the snow tell is still useful, but if the ASOS station has snow depth, then particularly on the East Coast where we might not have that, we could use it. So yeah, let's look at the different parameters, I guess, and then figure it out from there. So we can actually go back now to our data. We're gonna make a new schema, so we'll start by copying the other schema. So weather schema, that's what it's going to be. So we're gonna have station ID be kind of the main thing. Station ID. And then we'll just kind of edit these one by one. So let's actually throw up. No, that's not what I wanted to do. I want to copy these things so I can kind of see what's going on. So looks like we have station, valid, temp F, dew point, RLH, etc., etc. So station ID. So this is going to be the ID of the ASOS weather station. And again, this table will just be for the ASOS kind of weather data. It won't be for the temp F. So it won't be for the other types of data. I think, yeah, that should be a float 64. The other types of weather data. So there are some other weather data networks later on we might pull data from, but this will not be one of them. This would actually be a good time to really actually have 2 screens, because you'd throw this on the other screen and then do that. But we can just do it this way. Dew point F. So this is going to be, well, let's update this name first too. Yeah, so it actually was right there. Dew point F, this is also going to be a float 64. So this will just be the dew point in Fahrenheit. Actually, for this, we probably actually long term too we'll maybe create like another table of the stations based on station ID. Because if we do state here, it's just gonna get really repetitive. So but yeah, that's something we might do later. Let's see. So I don't think it's included there. Yeah, so it's not included here. So we won't include it here. Later on, like what we'll do, I think maybe is then create like yet another table, which is like, what do you call it? I think you'd call it a fact table. If I remember my... or I forget what you call it, but it would store essentially the info on the stations. In any case, we won't include that here, so I'm actually just going to quit out to not slow the rest of my stream down of these various things. Preview Safari. So yeah, those are the major ones. So again, dew point RLH. I don't know what RLH is. History. Oh, so that's relative humidity. That's probably not as important, but we'll just include it now. I mean, we can always calculate. We should always be able to calculate relative humidity. But in any case, that would be RLH. I think we'll put this as a float 64. And then what we'll, so this is kind of tedious, but I think it's probably the most efficient way of doing it. I mean, you could also then just write it itself, but then you have no real set schema, I don't think. So that could become problematic. So direction. So some of these we do want to put nullable in. So the core things we definitely need are precipitation, temperature, dew point. Those are ones I really do want in all of them. Some of them, these extra fields, we don't, we can make nullable. So this would be one of them. This would be none of that. One of them. Direction, sknet. What was sknet? Oh, I think that was by default actually recording precipitation in, or is it all of them? Oh, here it defines them. Sky level coverage. Wind speed in knots. I guess that could be useful for certain things. Probably not as much for stream forecasting. Wait, knots. I don't know if knots you can have are knots always an integer or is it a decimal? Let's see. Okay, I guess you could have decimals, so we might as well make that a float. I'm not very familiar with knots. So yeah, let's actually just keep their descriptions for these. Wind speed in knots, latitude. What was that? No, that was Safari. P. I actually did want. I did want precipitation to be in millimeters generally. So I don't know if all available just automatically gets it in inches. Oh, shit. Let me look at this. Comma. I think they're just doing inches though here. I think part of the problem is if you get all, then it's in inches. But if you like specify the parameters one by one, it's in millimeters. Let's see. If we do this, no. Ugh. Convert. I mean, we could convert it to, I guess. I mean, because, yeah, the good thing about millimeters definitely is that it's a bit larger. Like an inch of rain, if you got an inch of rain in a place, it's actually quite a lot of rain. And I guess it shouldn't matter too much what goes into the model. Let's call this percip, and this should not be nullable. That should be required. Okay, so I guess we'll have to write code to convert that or do the parameter, because yeah, I do. The thing is, I have a previous version of forecasting models, and they were all trained in millimeters, so I mean, actually, it probably shouldn't matter too much since the data was scaled, but I do want to keep it consistent, so we'll have to like make sure the code either converts it before saving it or just pulls in millimeters. In any case, we can do the rest of these. Pressure. Was there a snow thing? I saw snow there somewhere. Snow depth. So I saw snow depth. Yeah, it's right there. Snow depth. Okay. Yeah, I don't know how useful some of these other things are. Wind gust. Sky temperature. Okay, so we can do yeah, we can do that, I guess. Alt-D. Floats. But yeah, that can definitely be nullable. Is that right? Suggestion. Pressure, alt tilt. Visibility. Yeah, it's hard to know because like I think a lot of these fields could definitely be useful. We definitely want the snow depth though too, so I'm gonna do that. Snow depth. Is that in inches? Does it tell us what the snow depth is? Let me see. Okay, so yeah, I think that's inches. Though I guess it would be weird if we converted one to millimeters and not the other. Yeah, I guess for everything we'll just put it in millimeters. Because yeah, if we convert one, then we're... Though of course it's also weird, I guess, to have millimeters and not in Fahrenheit and not Celsius. But that's what the previous models had too, so I'm going to just stick with that. Sky 1. Ice secretion. Yeah, I don't think gust. Maybe gust. I guess gust and visibility, and then maybe sky 1. I don't think it's worth putting in like 4 different fields for the sky, probably. So let's see. Let's get these one by one. So let's do visibility. So that will be, I think that would be a float again. Visibility in miles. Okay, gust. So we can make this, I think, gust. So yeah, gust. So that again, I guess all of these are going to be like floats. Sky RC1. Okay, so we just need this one. No. And that should probably be good. Sky level coverage 1. Wait, what should that be though? I don't know if that should be a string or what. I think these are good. Yeah, I mean the big three, of course, are temperature, dew point, precipitation for the forecasting, and then snow depth is useful. I'm gonna check what sky coverage 1 is. So let's get that, or actually, I don't know. I want to get everything again. I'm gonna actually open this in numbers, I think. What? That's definitely a CSV file. So yeah, let's just check this in numbers, see if it makes like intuitive sense. So this is a string, it looks like. We also have to write code, so whenever we see M, I think we just do Yeah, wherever we see M, we just do, we put it as none, I think, so. Into the table. So, sky, C1, so that's a string null. So let's check the schema. I think this is basically what we want. I'm going to check peak wind, snow depth. I feel like a lot of these are just going to be missing for everything, so might not be worth having them. Like there's some columns that might, like what's this Q1? Sky I1. What's that? Yeah, we could do feel too, I guess. That's not quite as important since it's the calculated value. We might as well just add it. So feel, and then this would be like, I mean, probably don't need float 64s for all these. But float. Numeric types. I mean, yeah, it would be. Yeah, we can just use float 64. I'm not gonna worry about that now. So what we can do now is do oh yeah, we need to change the name. Oh yeah, we haven't actually added the code for it yet. But okay, so I'm not gonna do the scan stuff. Oh yeah, I need to go in the right repo first actually. So I'm not gonna do the scan table now. I hadn't really created it yet anyways, so I'm just gonna use this for it. So I'm gonna call this weather data, and we're gonna call it weather. Labels, environment default, weather. I think it, what did we call it? Yeah, weather schema. So that should be good for that. So we can go in there and then run our Terraform commands again. Flow. And we're going to do Terraform. Well, Terraform init. Just to do that, Terraform plan. Should say like adding one table. Okay, that's basically what we want. So yeah, we'll check that. And we'll go ahead and apply. Yes. That's what we want. So yeah, there's still that problem with the Terraform state and the whole Google buckets thing. But hopefully it's the table was created. So yeah, let's see. We'll go back to this other project. So in BigQuery, we see the table was created. Oh shit, did I call it the wrong thing? Where's that? Wait, why am I not seeing the table? Oh yeah, it's under this thing, I think. It's under the HydroNet, yeah. Okay, there it is. Basically that's kind of the different fields we have. And yeah, everything looks good there, pretty much. Oh shit. Fuck. Shit, I just remembered that was... Oh shit, yeah, I just missed something really important. We didn't actually add the stupid date time to it. That was like a huge thing. Oh, don't do that. Come on, stop suggesting that shit. Shit, yeah, I can't believe I forgot the date time. That's like a huge part of it. We can copy this one, I think. Or wait, no, we didn't use a date time there. Yeah, we definitely need a date time. So name, yeah, type, timestamp. Let's see. BigQuery time types. I think it's probably is that. Date. So it's date time. Oh wait. Wait, what's the difference between date time and timestamp? Okay, I think we can use date time, not timestamp. Yeah, that's right. Weather. Ah, shit. That is not what I wanted. I think if we just run it again, though, it will basically, what is it, perform a migration or something. Or the BigQuery equivalent of it. Yeah, we don't need to init, actually, since we just did it. Oh, shit, did I just apply? Yes, sir. Yeah, that looks fine. Let's see. Let's see if the table was... Well, at least we did notice it before we tried writing any data to it. The date and time of the weather observation. Okay, so... I don't know why that's shown as last, but so this is going to probably in the end be a huge table, because we're going to be, I think we have at least like 300 or 400 ASOS stations, and hopefully most of them actually have data going back at least 20 or 30 years. So if you have daily data that's 60, or daily data going back 30 years, 24 times 365 times 30, and then you have something like 300 stations. That's already like, yeah, it looks like it could easily be like probably 80 million rows or so. So it will be, well, I don't know if people would consider that truly big data now, but it will be a pretty big table when we write all the shit to it. So yeah, so that's what we're going to do there. Today we were just creating the table. I think we'll break this up into two, and then tomorrow we'll actually try adding data to our scraper to basically when it scrapes, when we run a scraping job, have it cache data to this table, and that's where the BigQuery connection function will come in. So tomorrow we will update our scraper to do that, but I think we'll probably end there for today if I didn't. Oh shit. If I didn't forget anything else, I think I probably should update the description there. Shit. So date time. I forget, like, Terraform table partition by. We might want to start creating the partition now. And obviously that would be by the weather station. And then also the time. But yeah, that's more, I think, when the table gets bigger, so we can do that a bit later, and not at the moment. But yeah, that was kind of creating the table in Terraform. Likewise, we can probably update our code on GitHub. So that should be fine, and then yeah, I'll just update that field quickly. I think all it does is update the description, which is fine. Okay, so we should be good now. We'll be back to, I think, tomorrow, and then we'll actually write to the table. Yeah, I'm trying to keep these a bit shorter in length, so there wasn't one like marathon long video session. So with that said, we'll, I think, end it right here, but definitely do another stream tomorrow.